No, circuits week 5, right? What were the topics that were taught this week? Can anyone let me know quickly?
The week 5,
Yeah, week 5.
gain margin, sir. Gain margin.
Okay.
Then frequency compensation.
And what else?
Then about filters.
Okay. Circuits week 5. So as has been the practice in the previous 4 weeks, we'll be trying to solve the problems. I mean, I had given one homework problem to all of you at the end of the week 4 session. Uh, I did not get any email response with respect to that problem. So I'm assuming all of you were able to do that. So we'll proceed on week 5 now. So the problems that I'm planning to discuss today would revolve around the effect of the feedback and stability in the system, okay, on the system. The stability and the pole location, uh, and yeah, these would be the broad topics that I'll be doing problems on, that we will be doing problems on, rather, right? But this is the first one. Okay. So consider the following feedback arrangement. Suppose this is block A, this is block beta. Okay. So if this is the feedback arrangement, uh, and suppose your X naught is 0.5 volt, rather, this is 0.5 volts. Okay, and your XF, suppose that is zero point 0.5 volt. Your XS is 1 volt. You need to find what is XI. Simple problem, right? So how should we proceed on this one? Anyone? What is XI? XI is what?
XS plus beta X naught.
How does this summer work?
xs minus beta x
Yeah,
naught.
this sign is for xs, right? And this minus sign is for the signal that is coming here. What is the signal that is coming here? It's x naught times
Beta
beta,
x naught.
correct? And yeah, we actually already know this signal as well, right? Do we? The feedback signal. I mean, the signal that I wrote here is this one. Okay. So what is xi? As one of you already said, rxi would be xs minus xf, right? What is xs? 1 minus what is xf? 0.5. That is zero point 0.5 volt. Simple. Is it clear?
No need of considering beta.
Why would we consider beta? Oh, if this xf would not have been given. Suppose instead of
Okay.
mm, got the point? I mean,
Yeah, okay, understood.
in other words, let's say I did not give you this one. Okay. I told that instead your beta is 1. Then what you would do is then you would multiply this x naught by beta, which is again zero point 0.5, and then you would subtract this zero point 0.5 here. Your xf is nothing but your beta times x naught. Okay, I guess this was a simple problem. Let's proceed and let's consider the same feedback arrangement that I had shown in question 1. Okay, what if I do following? Let's suppose your x naught is 5-fold. I want you all to do this. I mean, these are pretty simple problems, right? And you all are expected to do this. So if your x naught is 5-fold, suppose your xf that is 0.5-fold, your xs suppose that is 1 volt. Can you find A? Need an answer. I'll wait for 2 to 3 minutes. How would you find A? What is A first from this feedback arrangement? I mean, your x naught is A times xi. Is that clear? Somebody answered it correct. The correct answer is 10, but still, let me go through the solution. Am I correct in saying that your x naught is nothing but A times xi? Then what about this xi? My xi is xs minus xf, xs minus xf, that is zero point 0.5. So this is 0.5. The x naught is A times 0.5. What is x naught? So 5 is A times 0.5, which gives your A as 10. Is this clear? Okay, let me proceed. So now let's take up another question. Question 3, okay? Let me think about that. What if I consider the same uh, arrangement, okay, and suppose I tell you that your X naught is 5 volt, your XF is zero point 0.5 volt, right? Your XS is 1 volt. Can you find beta? If so, then what is the value of the beta? Two of you answered it correct. The answer is 0.1, which is 1 by 10. So again, for beta, what would we do? We would write your XF as beta times X naught. This is given, right? What is X naught? 5 XF. So this would imply our beta has to be 0.1. Okay. Okay, now let's do one thing. For the same question, okay, what is the amount of feedback? Okay, you need to find that. Okay, I mean specifications are same, arrangement is also same. All you need to do is find the amount of the feedback. How much is that? Anyone? What is the amount of feedback for this question? coming from your control systems theory, you know that it would be equal to 1 plus A times beta, right? And what is 1 plus A times beta? That is 1 plus 10 times zero point 0.1, right? Because see, the specifications are same. A we already calculated. We computed beta in this one. The amount of feedback would be 1 plus 10 times zero point 0.1, which is 2. Correct? Somebody wrote it as 1 by 2, but no, it would be equal to 2. Okay. Now let's take up another one. Feedback arrangement is shown. If x naught, x f, x s. What about if I keep the same set of specifications? Suppose I keep x naught this, x f this, and x s this. Okay. What is the closed loop gain? Closed loop gain would be correct, 5. How would it be 5? You may even unmute yourself and explain it.
A by 1 plus A beta.
Correct, yeah. The closed loop gain simply be A by 1 plus A times beta. This we already know it's 2. A is 10. So this is 5. Okay. Now let's consider another one. Let's consider op-amp now. This is VDD. This is R. Suppose this is GM of VG, obviously. And this is ground. Is this correct? Okay. Let's consider this circuit. Looks operationally fine. Okay. So suppose that I want you uh, to have a negative feedback in the system. So what should be the signs of A and B? Obviously of the op-amp. Okay, should I repeat it? If if this is your system, okay, and this is our op-amp. So remember we had those non-inverting and inverting terminals in the op-amp. I'm not explicitly mentioning them. Instead, I'm using variables A and B. I want you to tell me what should be for non-inverting terminal and what should be the inverting terminal. What should be A, what should be B, such that this whole system would be in a negative feedback. Okay, let me write the question. For negative feedback, uh, AB signs of AB should be what? Oh, sorry, I was mute. So A would be the non-inverting terminal and B would be the inverting terminal. Correct? Only then would the system be in a negative feedback. Right? Our input has to get to a inverting terminal. Now, one more thing. Now assume that this op-amp is ideal. Okay. If you assume that this op-amp is ideal and obviously in the negative feedback configuration, can you find VDD by G? That is our question 7. Okay, this is a follow-up question. What is VDD by G? For that, first you need to find what is this Vx, right? How much is this Vx? Am I audible? Yeah. So how much is this Vx? And this Vx would simply be VDD by 2, right? Virtual short. So if this is VDD by 2, this is VDD, right? So yeah, I can compute the current, right? How much is that? Well, the current flowing through this resistor is nothing but, suppose this is I say X, right? And I can write that this Ix is nothing but this is VDD minus VDD by 2 whole divided by R. But that is equal to what? This current, so this is a current source, right? So, I mean, this would force that this current flowing is GMVG. Okay, so this is nothing but GMVG. Okay, so this implies that VDD by VG is how much? 2 GMR. Is that fine? Is this fine? Okay, now then we can proceed to next question. Question number 8. Let me so this is what would be the circuit for this question 8. Okay. And what do you need to find? Uh, I want you to find the signs of these A, B, C, D, E, F. Okay. You need to find all these signs for the negative feedback in the op amp. So what should be the signs? Anyone? What about A and B? A should be what? Negative, and B should be positive. What about C, D? Well, D has to be positive, right? So, and this needs to be negative. So CD would be negative, positive, inverting, non-inverting. Likewise, our EF, what would EF be? EF would be F needs to be inverting. So this would be plus minus. Is this correct? All right. So that was question 8. And then we have question 9. Okay, so this was for what? For negative feedback. Right? Or I should say for negative feedback in output. The signs that you should use is this. Now question 9.
Repeat question number 8 again.
Okay, repeating the question number 8. Okay, so we had to choose the signs for these A, B, C, D, E, F. In other words, we had to decide which one is going to the inverting and which one is going into the non-inverting. And the condition that we were given was that op amps are in negative feedback. Okay, for the first one, uh, this input should be fed into what? It should be fed into the inverting terminal for this to be in the negative feedback. So that's why I chose A as minus. B would be positive, right? Similarly for this one, C and D. Now D has to be positive, right? And this I would treat as input that is going into the op amp. So C is minus. So that's why minus plus. Then what about this? I chose this as plus and this as minus because I'm assuming that feedback from the output is going into the F terminal. That has to be the inverting terminal, right? That's why F was minus. Is this clear?
Okay, sir. Clear.
Okay, I guess now I'll move forward. And now for question 9, let me again take a pick. Okay, suppose we have this one, right? And this is the circuit arrangement that you need to consider. And these blocks are placed in the negative feedback configuration. Okay, you need to find the value of the V output voltage by input voltage. In other words, you need to find VO by VI. What is VO by VI? How would we compute that? If I apply KCL, okay, if I apply KCL, okay, this is V input, right? My virtual short. This would be V input. So V output minus V input divided by this would be the current flowing, right? And this would go directly to this. That would be V in by V R5, right? Another what I'm trying to say is funny. Since this is V input, so this would also be V input, right? And if I apply KCL, I want to apply KCL at this particular node. Okay, current going in is this, current going out is this. They have to be equal, right? What is current going in? That is this node voltage VO minus V input by R6, right? So VO minus V in by R6. How much is that? That is V input by R5. Is that fine? But we are interested in VO by V in, right? So let me mathematically manipulate this equation. So V output would be how much? V input into R6 whole divided by R5 plus V input, right? So that would give us that V output by V input is how much? 1 plus R6 by R5. Is this correct? It is, right? So that is what will be the answer for you. It's 1 plus R6 over R5, or in other words, it's R5 plus R6 whole divided by R5. Okay, now let's take another one. For that, I guess I need to again take a snap, or is this the same circuit? A, B, R1, R2, C, D. Let's say this is Vx now. Let me copy this. Suppose that this is Vx. Okay. What would be Vx by V input? I mean, this is also same. I mean, I would say a similar question, and we would approach this in similar fashion as we did for the previous one. See, this is Vx, so this is also Vx, right? And this node voltage is Vx, similar to how we said this would be V input, right? Virtual short, virtual short. And then I would use KCL at this node. Current going in is current going out, right? What is current going in? Write an expression for that. That is VO minus Vx whole divided by R4. And that is equal to what? This particular current. This is what? Vx minus 0 divided by R3. Vx by R3. Right? So I can write VO as Vx into R4 by R3 plus Vx, which will give me VO by Vx. VO by Vx. Oh no, sorry. I have VO by V input. I need to compute let's try to compute V in over Vx first, okay? I mean, what is Vx by this? Okay, let's proceed step by step. So your V output is nothing but Vx times R4 by R3 plus 1. Correct? And from this, Vx would be how much? V naught whole divided by 1 plus R4 by R3. Now, V naught I already know in terms of V in from this, right? And I have to write this Vx by V in expression. So I'll use this. What is V out? That is V in times this, right? I'll write this as V in times how much? 1 plus R6 by R5. Correct? Vx by V input is how much? Okay, so this would be the expression for Vx by V input that was S. Is this clear how I did this? I hope it is. And in fact, these were the 10 problems that I was planning to take, or I would say show today. So I'm done with my portion. Is there any question from today's session? Especially from the last two questions? I hope there is not, but if there is any, feel free to ask. I'll wait for, I guess, 2 to 3 minutes. You can perhaps comprehend it and let me know if you have any question. If there are no questions, then we can perhaps end the today's meeting. It was a short one, but we did around 10 problems today. And if you, after watching the recording, if you feel you have any question, you can mail me as well. And also, I'll be uploading today's slides in that folder as well. Okay, the week 5 slides. We have now 3 more sessions to go since this is an 8-week course. Right? Today was 5th week, so we are done with 5 weeks. All right. See ya.